Hello and good day, everyone. Thank you for inviting me to the Southeast Asia chapter of the World AI Conference, one of the world's largest AI conferences. And I'm truly honored to be with a lineup of industry experts sharing insights on a significant topic that is the power of innovation with AI as the game changer in the new world. Ladies and gentlemen, at the turn of the century, the world was confounded with a virus which brought it almost to a grinding halt. It was called Y2K. Shortly after, a new normal emerged. All things multimedia and software became the buzz. The internet took off, and information communications technology bubbled million new ideas and inventions. Then 10 years ago, cloud computing, Web 2.0, and smartphones became the new thing. 5 years forward, e-commerce, mobile applications, and so on became mainstream. Fintech and the sharing economy came about, even as opportunities in artificial intelligence, data science, cloud computing, 3D printing, and Bitcoin looked amazing. 2 decades on, the world finds itself confounded with yet again another virus. We are now battling the COVID-19 pandemic, and we are finding ways to adjust to another new normal as we navigate through this pandemic. However, some things remain: the impact of technology and its importance to move nations forward. Many countries are facing a long and hard recovery, but technologies such as AI plays an important part of the recovery effort, helping to boost productivity and foster a new generation of innovative tech companies. In 2018, PwC estimated that AI advances will increase global GDP by up to 14% between then and 2030, the equivalent of an additional 15.7 trillion US dollars contribution to the world's economy. Around 6.6 trillion US dollars of the expected GDP growth will come from productivity gains that include the continued automation of routine tasks and the development of increasingly sophisticated tools to augment human capabilities. Driven by rapid population growth and economic development over the last few decades, Southeast Asia is slowly switching from becoming a participant in the global trade to a chief architect of its own future. Now, Malaysia is uniquely positioned to capitalize this, as we all know. In fact, our main opportunity lies in leveraging ASEAN as a platform and foundation for growth. As the world's fifth largest economy in 2018, Malaysia has access to a market of 630 million people and a GDP of around 3 trillion US dollars. The ASEAN market is expected to skyrocket to 5.2 trillion US dollars by 2025. However, Malaysia faces a slow adoption rate of IR4, with only 15 to 20% of companies have actually embraced IR4. International Data Corporation, IDC, in 2019 revealed that Malaysia's workforce was unprepared for IR4. While we have one of the highest manufacturing output levels in the world, we are actually lagging behind other countries in terms of employee productivity, R&D, and the workforce with higher education degrees. The common challenges faced by Malaysia include the lack of awareness and the impact of IR4 and its technologies, thus reducing the chances of exploring opportunities and the disruption of business models, as well as shortage of the necessary skills, talents, as well as knowledge that is required to adopt to IR4. This is true especially in areas such as AI, IoT, robotics, cybersecurity, and many others. But as the pandemic has led us to face the most uncertain period of our lifetimes, the adoption rate of technology has to be accelerated. And AI is set to play an extremely important part in this. The pandemic has exposed gaps between competing businesses and those that were slow to transform before are feeling the urgency to do so today. Fortunately, new technologies, which include data analytics, AI, and connected devices, have come to the rescue to manage the pandemic disruption globally. Ladies and gentlemen, as a CEO of a government agency, my role principally is to oversee commercialization of local innovation towards globalization, and one that is equipping Malaysia to be better positioned to tackle issues such as low commercialization rate, low gross domestic expenditure on R&D, or better known as GERD, low R&D spend by the private sector, as well as overlapping roles between government and the existing agencies. The landscape for innovation continues to evolve at a furious pace for both the tech startups as well as the tech giants. We really have to speed up the rate of commercializing our technologies and innovative solutions in our push to make Malaysia a high-tech nation. COVID-19 has done nothing but put us on an overdrive. A recent report highlighted Malaysia's digital economy contributes to 1/5 of our GDP, and we're the second most digitally advanced nation in Southeast Asia. In April this year, the government announced that Microsoft will establish its first data center in Kuala Lumpur. This project is estimated to cost $1 billion and is expected to create 19,000 jobs and generate over $4.6 billion in revenue for the country. The data center is a core part of Bersama Malaysia, or Together with Malaysia initiative aligned to Malaysia's economic growth. This initiative will help skill an additional 1 million Malaysians for IT, artificial intelligence, and cloud services jobs by 2030. Last year, Malaysia was ranked 33rd out of 130 economies in the Global Innovation Index 2020, improving 2 ranks from 2019. Malaysia ranked second among 37 upper middle income economies and 8th among 17 economies in Southeast Asia, East Asia, as well as Oceania. Not resting on its laurels, the government recently launched the National Policy on Science, Technology and Innovation, or better known as DISTIN 2021 to 2030, aiming to address the issue of innovation inefficiency. In efforts to make Malaysia a high-tech nation with a gross domestic expenditure on R&D or GERD to GDP of 3.5% by 2030, MOSTI has identified 10 socio-economic drivers with 10 global leading science and technology sectors to lead and empower Malaysia's economic growth. TPM, or Technology Park Malaysia, plays a very important role in supporting Malaysia's plan to accelerate commercialization for the country. We are doing so through key initiatives such as the National Technology and Innovation Sandbox, which is led by MAGIC, with close to 100 million allocated to this project. Target sectors include medical and healthcare technology, manufacturing, agriculture, education, as well as travel and tourism. Priority is given to technologies involving blockchain, robotics, sensor, advanced materials, drones, amongst others. It is where participating startups will need to have a prototype ready to be demonstrated in an operational environment. The sandbox aims to bring together the right players to create a clearer way for high potential advanced technology to hit the market, to be commercialized, and thereby boosting the rate of innovation for the country. It was decided that priority must be given to choosing technologies and solutions that will resolve problems affecting our environment and core economic activities, which will allow the country to rebound, in addition to transitioning to a low-touch and high-tech economy. That said, a lot needs to be done to achieve mass adoption of AI. The ultimate aim of accelerating the innovation and adoption of advanced technologies in the sandbox is to address the country's most pressing societal and sectoral issues. Creating high-skilled jobs and accelerating the economy is definitely one, for example. Increasing Malaysia's GDP, GNI, as well as improving social inclusion is high on the agenda. And of course, increasing the private sector's participation and investment in R&D into our innovation ecosystem. Ladies and gentlemen, coming back to TPM, we are positioning ourselves as the National Science Tech Park, which will incorporate 5 key components of an innovation hub for the country. The first one will be a living lab. Second one would be a commercialization center. Third, utilities infrastructure. Fourth, to provide experimental lab or test bedding. Fifth is to provide capacity and capability development tools to allow technology startups as well as entrepreneurs to be equipped with whatever is necessary to commercialize their business and develop technology. TPM is bound by the strongest obligation to fully support the National AI Roadmap 2021 to 2025, which will be a vital component to our technology commercialization accelerator journey. TPM welcomes new ideas, potential collaborators, and investors align with our first initiative of creating Malaysia's first AI park in the country. The AI park will be a designated 300 acres of land in a prime area of Kuala Lumpur. And we are looking at a total investments of more than R1 billion Malaysia, which will be deployed in the next 4 years. Now, this park is envisioned to serve as the platform for the development of AI solutions in niche areas such as computer vision, speech recognition, natural language processing, as well as robotics. Ultimately, the park will enable the development of technology and talent, data management, R&D, and commercial ecosystem, which could assist Malaysian government to address the data ecosystem and AI governance. There is a huge opportunity for AI to flourish in Malaysia. We are excited and encouraged by this ocean of opportunities. And the country is definitely one of the most promising spaces for innovation to flourish. And the government has truly invested in this idea, and AI is set to be the nation's growth driver for the near and the long term. We are truly proud to be part of this transformation journey. It is definitely a big step for us. And I'm excited to share this idea with you. And I hope to be able to share this experience with all of you again soon. Thank you for having me today. And I hope you will enjoy the conference today. Thank you.
Hi there. Good day to you, and welcome to the World AI Conference 2021, or known as WAIC, Southeast Asia chapter, in which we will discuss the subject matter on the power of innovation with AI as a game changer in the new world. This virtual conference is hosted by SkyMind Global. Our topic of discussion today will cover 2 areas. One is actually TM visions to create a digital Malaysia. TM here, I'm referring to Telekom Malaysia Berhad, and also the collaboration of our enterprise arms, TM1, with SkyMind that can accelerate AI adoption. So I wish all of you are staying safe and healthy during this unusual time, and hope this event will bring a lot of interesting ideas and also great sharing from us on our journey to make Malaysia a digital nation. All right, we'll start with the introduction on myself. So my name is M. Umapati Sivan, or you can call me Sivan in short form, and I am the Group Chief Information Officer for Telekom Malaysia Berhad, also as I mentioned earlier, is known as TM. Now, Telekom Malaysia, just to give you a background, is the largest connectivity and also convergent service provider in Malaysia. We cover the entire facet of connectivity, everything from providing the connectivity to home, businesses, and also to the government. And we cover on the areas of the traditional connectivity, where you have your phone lines, broadband services, but also on the end of providing cloud services and enterprise solutions for both the MNC and SMEs and to the government organization. Ladies and gentlemen, the first topic of our discussion today will be on the TM's vision to create digital Malaysia. So TM is anchored as the enabler of digital Malaysia because we are the largest connectivity provider in Malaysia. The fiber connectivity plus the home passes are our biggest business today. But we also are strong on the enterprise front, in which we are providing the large conglomerates, their connectivity, and also their enterprise solution on cloud, AI, and either technology solution. So to do this, we are flagged the Digital Malaysia by 2030, and this will drive a more digital society, digital business, digital industry, and finally, digital government. And we are attacking this on three fronts. Connectivity excellence, as I said, we are improving it. We're even working on becoming the collaborative partner with what do you call that, the Digital National Berhad, in which we are managing the 5G infrastructure. But more of this is anchored on the solution excellence, and which is the topic of the second discussion on how we are working with a strategic partner, uh, likewise SkyMine, in which we are accelerating activities on managing the vertical industries. And this is done specifically with SkyMine on the AI adoption. And then we want to drive, with all these capabilities, we want to drive customer excellence, because that's the ultimate goal, in which we can drive hyper personalization based on the requirement of the users. So when we come to the connectivity excellence, our goal is not only build the infrastructure on the connectivity front, but also on the data center front. As you guys are aware, TM Malaysia is Telecom Malaysia Berhad, or TM, is the one of the four chosen party to become the cloud service provider for the government. And as a local player, we have ensured that we manage this from the end of security, what do you call that, scalability, and more importantly, we are also anchoring solution on these cloud services of ours, especially on Cloud Alpha program of TM1. TM1 Alpha Cloud can actually provide both the um, hybrid solution, which includes our private cloud solution, plus our public cloud solution. And this is also powered with the partnership with multiple global hyperscalers. Now with that, we are gonna go towards driving solution experts. And this is the solution expert and excellency that we are working with multiple partners. One of them is with SkyMine. Now, what we are doing on the SkyMine front is our uh, Cloud Alpha solution is able to provide the scale, capability, and scalability that you will see on the global hyperscalers. And SkyMine brings their AI solution so that the adoption of the services can be catered for everyone from an SME to individual users as well. A simple example of that would be the capability of SkyMine to bring some of the platforms to develop, to enhance, and build AI capability on top of that to drive this thing. Now, we are embracing the same thing here in TM, and especially in my organization, Group IT and Digital. Our goal is to build the same goal, and we have anchored that based on our vision of making our organization lean, our processes mean, and our technology clean, or we known as lean, mean, and clean. This is anchored on the structure of making the people, process, and technology part simple, standard, and stable. And how does AI comes into the play? Well, we will not be able to achieve this if we are not using data-driven capability that we have and anchor more hyper automation that will allow us to be able to reach out to a bigger audience and needs now and in the future. We're doing that in multiple areas. We have established one of the largest RPA organization or robotic process automation, and we're trying and we're looking into expanding this capability not only within TM but also to the external partners. And we are also looking at anchoring the AI capability of big data and machine learning and enabling that for data insights, better planning capabilities, and also being able to ultimately make customers more happy with our services. And in the last bit of this discussion, we want to again discuss about our collaboration with SkyMind. We are hoping that the program that we are doing today will continue to embrace more digital business, digital society, and as I mentioned, digital industry, and being able to support our government to become fully digitalized. Thank you and have a good day.
I'm Adam Gibson, the CTO of SkyMind, and today I'll be presenting on AI accessibility and the future. So I'll focus on two core topics today. What are the trends and the problems today? What I mean by that are, what are we seeing in today's AI environment? Like, how expensive are things? How easy is it for people to build custom AI? What does it take in order for people to actually try to use AI today? And then, after we present these problems, then we'll present kind of the solutions in the future. So what are we doing to address these problems? And what are we hoping to see as the outcome from those developments? Starting from today, models are getting bigger. So if people don't know what AI models are, they're essentially the thing that tells the computer what a cat or a dog is, given a picture, or what some text, what it should say next in response to some text. It's what dictates the responses to our questions. So AI models are just basically math, trained using, I guess, what you could call simulations. A computer tries to solve a bunch of math problems, and eventually out comes a configuration that allows it to kind of emulate intelligence through running math. So these models generally need tons of compute power because they leverage very, very powerful processors. Many that you cannot run on just your local laptops. So you may have heard of these things like GPUs, graphics processing units. Graphics processing units started as an alternative to CPUs, and they were very specialized at one thing: displaying things on a screen. The math behind displaying things on a screen and the math that you use to open Microsoft Word are very different things. And so eventually we started leveraging these different processors for math, in AI. This started happening around 2009. So the model started very small, and the compute requirements were not very much. But as the years went on, we're about probably more than 10 years into this now. We see in 2014 there's 135 million parameters. So again, I mentioned before, AI models are just running essentially math equations, and parameters are just individual numbers in those math equations. So the number of parameters is actually very large now. We started at 11 million, which already sounds like a lot to a lot of people. For example, in statistics, you typically only have 2 to 4 parameters for a given problem, maybe up to 10. But in machine learning, we completely brute force what I'll call pattern recognition, or just computers attempting to make decisions with tons of parameters. And so in today's environment, where we're running deep learning mainly for computer vision, speech recognition, things that essentially that humans interact with on a daily basis, we use tons of parameters. And so each of those models can be anywhere from 11 million to 135 million parameters. And we've only, now today, just, not even a couple weeks ago, we were doing 1 trillion parameters. And, just last year was 175 billion. So for normal people, they may benefit from these services because Google and all these other people are building these models. Google, Facebook, all the big social networks. They're, so they're, for end users, they're benefiting from this somehow. But in order for this powerful capability to be unlocked, things, not everybody has this compute power. So things should be ideally cheaper, but instead things are just getting bigger. And so it's that being said, it's also costly to train these models. So, when you have a larger number of parameters, it actually takes more money to build these models. So, for example, a billion parameter model takes $1.6 million to train from scratch. So when we say hardware, hardware cost is expensive, we typically mean GPUs, as I discussed before. They're better at running these AI workloads. Generally, they're running in the cloud, and generally they're very expensive. So we generally compute the cost of AI models in compute hours, and compute hours are just the number of total hours across all machines that you use to run these models. And so that ends up being, that the higher the parameter count, the larger it is. I mean, even just for some, just say an academic, university student, they probably don't even have $2,500. They probably don't have $2,500 even. And then the industry AI research labs like Facebook and Google generally have $1.6 million minimum. And that doesn't even count what it took to probably build, the trillion parameter model that they're doing now. So costs are increasing. And many state-of-the-art results are not replicable by, independent researchers. So what does that mean? That means that no one outside of Google can, if Google publishes a paper, no one outside of Google can actually reproduce the results. Reproducibility in AI is important, if only to make sure that the claims about, the results of accuracy and other similar benchmarks are true. And, being able to have anybody improve on the research presented. If only Google can make the claims and improve on its own model, then Google can do whatever it wants. And that's, that is what controls a lot of the direction of AI. So, generally what you try to do is you try to train on budget hardware, but it takes days to train. And that means you lose productivity. So what happens is what many people will do is they'll take these big models, because generally they're open source, and people will do something called fine-tuning. Fine-tuning means taking the core model and the patterns it recognized and just readapting it to a different problem. So typically this started in image recognition. So you would train something that recognized thousands of animals. It turns out that can then be used for other problems, bikes or what have you. Basically, it's just very good pattern recognition for color pictures. And so people will take these models and retrain them for their own problem. But that also creates, so while that does enable people to benefit from, some of these models being open sourced, and when I mean open sourced, I mean anyone can go on the internet, download it, and incorporate it in their application. But that being said, because of how expensive these models are to run, even just using these models can be very expensive. So what you might do, so due to this, not only are people locked in, but they're locked into expensive solution. So even if the big research institutions are leveraging their own compute infrastructure to train these models and give them out for free, it's still expensive and impractical to run them. So this is a big problem in not only computer vision, but also natural language processing. This natural language processing is kind of going through a little mini revolution right now. And, what's going on is, we're starting to brute force pattern recognition in understanding, text in different languages. So a lot of these bigger models have the capacity to understand 100 languages. So while that does have a large impact and is a net good, it's still not trending in the right direction. So we need to move for cost. So, we need to move towards being cheaper if possible. Another one, the last problem is, as something called concept drift. So, you see this. So what does this mean? This means the real world changes. So what your model learned 2 weeks ago might not reflect, what the world is today. So where is this a great example? Spam. So once automated systems learn how to detect spam, the people kind of generating the spam will slightly update their messages and try to get around the spam filters. Fraud and anti-money laundering is another one. You have financial institutions kind of battling fraudsters who try to figure out ways to kind of different ways to move money to essentially get around the bank's the bank systems that kind of detect fraudulent activity. So there's always kind of this adversarial approach of problem causer, automated system to mitigate said threat. So there's always a trade-off, and so model drift is kind of the threat of a model being out of date and not understanding what's going on in the real world. So software or code needs to be updated. And just like and on top of that, models are like code, need to be updated as well. But the problem is retraining can be hard and expensive. So what does that mean exactly? Retraining is where you take the model and you re-update it for today's state of the state of today, so to speak. So what are the solutions? So there's one concept called deep learning compilers. So basically in software today, we take plain code that anyone can read, JavaScript, whatever, and we compile it down to something the computer understands, zeros and ones. The equivalent is now being built for deep learning models. So I mentioned models are basically math. It's basically a series of math equations. That's code. That's just code in effect. So that's something that can then be optimized for specific chips, specific environments. You can even shrink the models down and make them cheaper to run. There's all sorts of alternatives to running models, run to GPUs as well. You have a lot of chips being built by ARM. You have new architectures that compete with Intel, like RISC-V. There's all sorts of different things we can optimize for, which means that, in the future, it will be easy to make deep learning run efficiently on any chip. That will make it easier for us to not only switch to different providers of hardware, but it will also make it easier for bigger models through optimization to run on smaller devices, which means that other people can replicate results and we don't have to spend $200,000 just to retrain a model. And this will open up AI applications to smaller companies, individual researchers, and it will also reduce vendor lock-in. So why is that important? It's so we don't have one company kind of dictating the direction of where the field is going. And then finally, open source tools will make it easier for anyone to set up production stack. So what does that exactly mean? So again, open source software is just a way is just make it so that code is available for anyone to download and use in their own applications. So the tools are AI tools, ways to build models, like the aforementioned deep learning compilers, among other tools that are available, whether they're through research or just published as open source by different companies. So, if you know what you're doing and you have skills, you can take open source and assemble it for your own use case, enabling you to actually build models yourself. And it also enables you to benefit from the cutting edge research happening in the field today. So while it may start as expensive, through time, it will be easier to not only reduce the cost of the training and the consumption of AI models, but then also to keep them up to date. Thank you for your time.